Precalc chapter 5 section 4. So we're going to be using the sum and difference formulas. We're going to use those to evaluate, verify, and solve our trig functions. And so these are the sum and difference formulas. So it's when you have the sine of the sum of two angles or the subtraction of two angles. So let's start with some basic ones here. So if we have the sine of 75, that's not on the unit circle, so we can't find that exact with the unit circle. We could plug in the calculator and approximate, but we could use our sum and difference formulas to help us find the exact value of this. So we have to realize how to write 75. So sine of 75 can be written as sine of 45 plus 30. Now why did I choose those numbers? It's because these are on the unit circle. So we're trying to find the two add-ins that are on the unit circle that add to be 75. And so that's how we're going to set this problem up. And so if I'm expanding that using our formula, it's sine of the first angle cosine of the second angle plus sine of the second angle cosine of the first angle is how I go through that so I know it or have it memorized. And so I need to evaluate this now. What is the sine of 45? That's going to be our root 2 over 2. And so I'm just using my right triangle trig, my unit circle. Cosine of 30 is square root of 3 over 2. Sine of 30 is 1/2. Cosine of 45 is root 2 over 2. And so we can multiply these together, each term. So then we get square root of 6 over 4, square root of 2 over 4. So they already have common denominators, so I just write that as one fraction, the square root of 6 plus the square root of 2 over 4. So we can do it again here with the cosine of pi 12, so it also works with radians. So a little more difficult for students to get this because they have issues with factors of this. So we're looking for two angles that add up to be pi 12s, but we want those angles to be on the unit circle. So sometimes it helps students to go through the first quadrant on the unit circle, the pi 6, pi fourths, pi thirds, and pi halves, and change those into the common denominator for whatever the problem has. So the problem is pi 12ths, so that would be the same thing as 2 pi 12ths would be pi 6. I'm just multiplying our numerator and denominator to have the common denominator 12. So this is going to be 3 pi 12ths, 4 pi 12ths, and 6 pi 12ths. So now I can use these and say which of these are going to add up to be pi 12ths, or I can subtract them. So it's a sum or difference. So for the pi 12ths, I'm going to subtract. And so I'll take these top two, the 3 pi 12ths minus 2 pi 12ths. So this is equal to cosine of 3 pi 12ths minus 2 pi 12ths, which is the same thing as the cosine of pi fourths minus pi 6. And I use those so I know the values in the unit circle. So we can expand that. It's equal to cosine of the first, cosine of the second, and this is how the cosines formula is written. And if you need to refer back to these formulas to see, you can do that. It's the opposite sign of what was written in the problem, so plus, and then I have sine pi fourths, sine pi 6. So now we just put these in the unit circle. So cosine of pi fourths is root 2 over 2. Cosine pi 6 is root 3 over 2. Plus sine pi fourths is root 2 over 2. And sine pi 6 is 1/2. So if I multiply, I get square root of 6 over 4 plus square root of 2 over 4, which gets the square root of 6 plus the square root of 2 over 4. Well, gee, look at that. Do you notice that these are the same? A better question is, why are they the same? Why is the cosine of pi 12 the same as the cosine of sine of 75? Why would those be the same? So think about that. I'll talk about it in class, kind of good connections to some of our previous. So here's another problem where you're given, you want to find the cosine of the subtraction of u minus v, and you're given what the cosine of u is and the sine of v. We don't know what the angles are. We're given the ratio that's equivalent to. So we don't want to find the angle, we want to find what the cosine of the subtraction of the two angles are. We're given some parameters here that our angle U has to be between pi and 3 pi halves. So that's the third quadrant. And then the sine of V, so the angle V is between 0 and pi halves. So that's the first quadrant. So just like we did first for last chapter, we should be drawing these. So let's draw angle U. So angle U is in the third quadrant. So we're going to make some triangle over here, angle U. And then we know our cosine is negative 15 over 17. So negative 15 has to be the adjacent, 17 has to be the hypotenuse. And so I'm just using my right triangle trig to draw that triangle. We also have our sine of V, so angle V has to be in the first quadrant. And so our sine is opposite over hypotenuse, so we have 4 and 5. And so now we can use our Pythagorean theorem. And we know this one already is 3, but we can use Pythagorean theorem to find the length of the other side, which is negative 8. And so the 17 squared minus 15 squared, and then you square root it, you get negative 8. It's negative because it's the y value going down. So now if we expand this, we're trying to find what cosine of u minus v is. That's what we want to find. Well, let's expand that. Cosine of u minus v is cosine u cosine v plus sine u sine v. And so, help us out, these are our v triangles. And so the cosine v and sine v have to come from the red triangle. And so just using our right triangle trig. So we have our cosine u, which was given to us in the original problem, is negative 15/17. Cosine v is in the red triangle. Using our SOHCAHTOA now, we can get 3/5. And then plus, we want to find the sine of u. So sine of u would be negative 8 over 17. And then the cosine v, or sine v, which would be the 4/5, which was actually given to us in the problem. And so this is equivalent to the cosine of u minus v. So all I have to do now is actually multiply, then add the fractions. So we get negative 45 over 85, and then plus a negative 32 over 85. So they already have common denominators. So we have negative 77 over 85. That would be the result. This is the cosine of u minus v. Algebraic expressions. So if we're given like our arcs here, back to chapter 4 again, we want to be able to use those to find the sine of the sum of these two angles. So arctan 1 is really the angle where the tangent is 1. Arc cosine x is the angle where cosine is x. We want to add those together and then find the sine of that. So to do that, we first need to look at what in the world arctangent 1 is, where that's at in arc cosine x. So if that's like x over 1, it might help us draw those. So if I make those two triangles, we'll do arctan here in red. Tangent is positive. The arctan has to be in the first or fourth, so I have to be in the first quadrant here. Tangent, I could write that as a fraction is 1 over 1. So my tangent is my opposite over my adjacent. So I have 1 and 1 there to then find the hypotenuse of that triangle. So that's going to be the square root of 2. And then let's do the other one, purple, cosine x. So it's also positive in the first quadrant. Let me draw that on a different axis so I'm going to confuse. So you have another triangle over here. Cosine is adjacent over hypotenuse, and so to find the opposite side, it's going to be the square root of 1 minus x squared if you follow the Pythagorean theorem here. So now we have our two triangles and all our sides measured for our two angles, so then we can actually find the values of the sine of the addition of these two angles. So to help you out, you could call this angle here, the red one, V, and then the purple one I'll call P. If I'm writing this out, the sine of really V plus P is what we're doing. And so if I expand that, it's going to be the sine v cosine p plus sine p cosine v. And you can color code that to help you out. There's our v's from the red triangle. I don't know why I didn't use r, but and then I used p for purple. So we can find these trig ratios from these triangles. So the sine of v was the opposite over hypotenuse, which is 1 over root 2. Times cosine p, cosine would be x over 1, plus sine p is going to be the square root of 1 minus x squared over 1 times, and then cosine v is 1 over root 2. So if I multiply it, x over root 2 plus square root of 1 minus x squared over root 2, which already have a common denominator. So this is going to be x plus root 1 minus x squared all over root 2. So we can verify them too. So we're going to try to verify this equation. So again, we have the difference here. So if I expand that, that's the sine x cosine pi halves minus sine pi halves cosine x. And we're still hoping we get to equal negative cosine x. So we can simplify a little bit here. Cosine of pi halves, that's actually 0. Sine of pi halves, that's 1. Well, that's kind of nice. Because this first term, sine of x times 0, that whole thing is 0. So you have a negative 1 times cosine x, which we are now done. This is negative cosine x. So the trig values just help get rid of the terms we wanted to eliminate. So we can also use these formulas to help us solve. And so if we were going to solve this equation, you can see how we have a sum here and a difference here. So we have two of the formulas within one equation. So we need to expand. We can rewrite these using our formula. So sine x cosine pi halves plus sine pi halves cosine x. And then we're going to do it again for the other one. So I'm going to add, and then we have expanding that is sine x cosine 3 pi halves minus sine 3 pi halves cosine x. And this still equals 1. So let's simplify some here. Sine x, can't do anything with that. But cosine of pi halves, we know that. We know it is 0. Plus sine pi halves, which is 1, times cosine x, plus this quantity, and we should have a quantity around here because we're adding that whole value. So watching our order of operations. So sine x cosine 3 pi halves, which is still 0, minus sine 3 pi halves, which, be careful here because sine of 3 pi halves is actually negative 1, and then cosine x. So nice, because we can eliminate that term and eliminate that term. Those are both 0. 1 times cosine x is just cosine x plus, and we have a minus a negative cosine x, which is just really plus cosine x. So then we get 2 cosine x equals 1, and so now we can solve it. Divide by 2, so where's cosine x 1/2? Pi thirds plus, and we're actually in 1 unit circle, so I don't need to include the plus 2 pi n. We have our 1 unit circle, so just pi thirds will be the first one, and then 5 pi thirds is the second one. So it's all within 1 unit circle. So we have to use our difference and sum formulas to help us expand it to get to ones we know that are in the unit circle to then solve. That is it.